Hi Math 1 scholars. Today we're going to talk about a second method for solving systems of linear equations called the equal values method. This method works best when both equations are written in slope-intercept form. So we want both equations to be in the form y equals mx plus b. Y needs to be by itself. When that happens, we take both equations and we set them equal to each other. So the right side of the first equation equals the right side of the second equation, and we solve that equation for x. Once we have the x value, we're going to substitute that in to the first equation and solve for y. So the end of step 1, we have the x value where we know those lines cross. At the end of step 2, we should have the y value where we think they cross. For step 3, we're going to be good mathematicians and check our work. We found our y value using the first equation. We want to make sure that it works for the second too. So we're going to substitute the x and y values that we just found into the second equation and check that we get a true statement. If we do get a true statement, we're done. We found our solution. We know where the lines cross. We move on to the answer. If we get a false statement, we need to go back to steps 1 and 2 and check our math. We may have made an algebra boo-boo while we were solving for x, or when we substituted in to find y. Assuming you get a true statement in step 3, we move on to step 4, where we write our solution as an ordered pair, x comma y. Let's try 2 examples together, and then I have one that I want you to try on your own in your small group. So our first example, we have the equations y equals 8x minus 19 and y equals 5x minus 13. Notice both of those are in slope-intercept form, so this is a good candidate for the equal values method. For step 1, I'm going to take the right sides of each equation and set them equal to each other. And that's going to give us 8x minus 19 equals 5x minus 13. We've seen equations like this last semester. When we have variables on both sides of the equations, we need to move one to the other. I'm going to move that 5x, and since it's positive, I'm going to subtract it from both sides. So minus 5x on the left, minus 5x on the right. On the left, 8x minus 5x is going to be 3x. On the left, I think I got that backwards. On the left, it's 8x minus 5x is 3x. On the right, 5x minus 5x is 0. So we're left with 3x minus 19 on the left and just negative 13 on the right. Now we're going to focus on the side with the variable, 3x minus 19. First, I have to undo that subtraction using addition. So plus 19 to both sides. On the left, that leaves us with 3x. On the right, negative 13 plus 19 is going to give us 6. So 3x equals 6. I know when I have a number next to a variable like this, that's implied multiplication, and the inverse operation is division. So I need to divide both sides by that coefficient 3. When I do that, 6 divided by 3 is 2, so x equals 2. So we know that these two lines cross at x equals 2. Now we need to find the y value that goes with it. So step 2, we're going to take that x value and substitute it into equation 1. Y equals 8x minus 19. Substituting in for x, we get y equals 8 times 2 minus 19. And now we evaluate the right side. 8 times 2 is 16. And 16 minus 19 is negative 3. So our solution, or suspected solution, is x equals 2, y equals negative 3. We're going to check that by plugging both of those values into equation 2. So equation 2 is y equals 5x minus 13. So substituting in for y, we've got minus 3 equals 5 times, and then substituting in for x, we've got 2 minus 13. I have to do the multiplication before I do the subtraction. So negative 3 equals 10 minus 13. And 10 minus 13 is negative 3. And that's a true statement. Negative 3 is always equal to negative 3. So we have found our answer. The solution to this system is 2, negative 3. If I were to graph these lines, that's where they would intersect. Let's move on to our next one. So our equations are y equals 2x minus 3 and y equals negative 3x plus 2. And they ask us to solve the equations by graphing and then to check using the equal values method. So I'm going to bring over my other window here. This is GeoGebra. It's very similar to Desmos. And I'm going to graph those equations. So y equals 2x minus 3. We see that red line show up. And then that second equation, y equals negative 3x plus 2. And I get an orange line that shows up. And you'll notice on the graph that intersection point was marked. If I click it, it tells me that those lines intersect at 1, minus 1. 1, minus 1. So let's keep that in mind. And we're going to really quick go through this process of equal values to solve for x and y. So step 1, we're going to set the right-hand side of those equations equal to each other. 2x minus 3 is equal to negative 3x plus 2. I'm going to move the negative 3x, and I'm going to do that by adding, because I know adding is going to undo that negative. So plus 3x plus 3x. On the left, that's going to give me a 5x. On the right, that negative 3, positive 3 will cancel. So we get 5x minus 3 is equal to 2. Focusing on the side with the variable, I have to undo the subtraction first. So we use the inverse operation, which is addition. On the left, the 3's cancel. On the right, 2 plus 3 is 5. So now we have 5x equals 5. I'm going to undo that multiplication with division. Dividing both sides by 5 gives us x is equal to 1, which is good. That's what we found with our graphing. We still need to check and find the y value. So step 2, we go back to that first equation and we substitute our x value in. So y equals 2x minus 3. I'm going to plug that 1 in for x. So y equals 2 times 1 minus 3. 2 times 1 is 2. And 2 minus 3 is minus 1. So this is good news. This matches what we found with graphing. We could probably be done, but I'm going to be thorough, and I'm going to do step 3 and check those values in our second equation. So our second equation, y equals minus 3x plus 2. I'm going to substitute minus 1 in for y and plus 1 in for x. So negative 1 equals negative 3 times 1 plus 2. Doing that multiplication, negative 3 times 1 is negative 3. And then adding the negative 3 and the 2, I get negative 1 is equal to negative 1. So we did that step correctly. So we can now write our solution as an ordered pair, 1, minus 1. What I'd like you to do in your small groups is take a minute and a half, 90 seconds, solve this one on your own. Okay. Once you've finished filling in this last example on your note page, remember to put it in your math folder so that you have it to turn in on Friday. You have the rest of the class period to work on an equal value zombie riddle for today, to finish the graphing zombie riddle from last class period, or to work on the homework that's due on Friday. If you finish all of those things, you should use that extra time to practice in IXL. And when I see you on Friday, we're going to be doing a second district assessment. If you have any questions, you can reach me via email. Otherwise, I will see you on Friday.